Okay, I've started recording, so we can commence. Hi, good evening, everyone. My name is Johnson, and I'm glad to welcome each and every one of us to this today's workshop. Our topic today is working at height procedure, and just like usual, we'll be having an interaction among ourselves, challenge our brains, reassess our competency, reevaluate our knowledge. So that's majorly why we are here. So I'm happy to to welcome all of you. And I'll commence immediately with, I'll share my screen. So I'll speak first. After me, I'll give the opportunity to Mr. Jamil. Then Olufemi follows. So in that order, we'll be able to air our experiences and our thoughts. I hope you can see my screen.
Yes.
All right. So we are talking about work at height. So majorly we'll be discussing work at height in all angles and in all spheres. There's work at height while walking on the roof, while using a ladder, while using work elevated platforms. These are all working at height. So we'll be generalizing all aspects of work at height today. Then while you are speaking on your own from your field, you can now specify it. You have the right to specify whatever aspect of the work at height you want to speak about. Okay, so I'll be start from generalizing the entire concept of work at height. Then individually we can specify it on whichever way we want to comment on it. Okay, so for work at height, we'll be concerned with some regulations like work at height regulation for EU law, Directive 2001. Okay, there are other regulations for work at height also that we'll look at later. So now, what actually is work at height? There are different definitions of work at height, but we'll be talking about work at height as any job or any activity that involves where you have the potential to fall. Where there is potential to fall, then we'll consider it out work at height. Initially, we used to give it a specific height, but currently, if you are working in any platform or on even in a surface level, and there is a potential to fall below, then we'll consider that activity as work at height. Okay, then let's talk about the statistics of injuries. We'll be talking about, we'll be using reference UK. So in UK, they said over 80% of falls are reported as low-level falls. So what this simply means is that you must not go above 10 meters or 4 meters or 5 meters before a serious injury could occur while working at height. So even falls at low levels could also result in injuries. Now, 40 fatalities to workers occur each year from work at height. And over half of these fatalities are reported in construction industry, which means most fatalities involving work at height occur in the construction industry. Okay, and falls from height account to about 60% of construction fatalities. So this simply means in the construction industry, falls from height gives you up to 60% of the fatalities that are reported. So we are looking at these statistics so that we'll be able to remind ourselves how serious the work at height is. Most times we take it so lightly. It's just walking on a ladder, it's just a 1.5 meter, or it's just 1 meter, and we overlook some certain things. So reflecting on these statistics will remind us that work at height activities are serious issues, and they should not be overlooked, and we should not wait until we've recorded the fatalities before we wake up. Okay, so this is an extract from UK falls statistics, falls from height, according to the years. Now, there are certain things we need to know, or we need to remind ourselves that before any job involving work at height, there should be proper planning. There should be proper planning. In some organizations, they find it difficult to present a work at height procedure. They think work at height is just take a ladder and climb up and do the job. But a procedure will help to guide your process. It will help to make an adequately planned process for the job. So work at height procedure is very, very important. Before any activity of work at height is commenced, work at height procedure should be prepared and should be readily available and should be communicated to everyone that will be working at height. Then the second thing is appropriate equipment must be used for that work at height. You see, in some situations, they do improvise. For instance, somebody that is working on a ceiling decides to use a table instead of using something like a well-guided platform, like a mobile scaffolding. So if the right equipment is not used for the job, so there is high possibility of an incident occurring. Okay, so work at height also should be done in good condition. Weather conditions should be considered. The condition of the environment should be considered. The ground level condition should be appropriately assessed before any work at height is commenced. Okay, now the staff or the employee doing the job should be properly trained. Work at height training should be made mandatory before anyone is allowed to work at height. Okay, I'll give some certain activities that we might consider low risk, but if properly assessed, you find out that something could go wrong. For example, changing a light bulb in your home, you might think it's a very low risk activity, you can just go up and do it. But if you don't do it properly, like the picture on the left, using chairs that could easily slip off, it could result in serious injury. So proper planning is very, very important, and use of proper equipment is very important. Okay, then use of doing the job in a proper position is also very, very important. So during the training, you should be able to teach them the proper position to on while walking, how to walk safely, and what not to do. For example, overreaching while walking on a ladder could be very dangerous and could result in serious injuries. Okay, so I will not take much of the time because our time is far spent. So I would like others to contribute at this point so that we'll be able to go around. Mr. Jamil?
Hi, good evening, and thank you very much, Mr. Johnson, for giving me this opportunity. And good evening and welcome to everyone. Thank you very much for joining this virtual workshop on working at height procedure. This is a quite important topic, and it's a huge topic. It cannot be covered in 1 hour workshop, but I'll try my very best to summarize it at a high level, some of the important concerns with regards to working at height. And I'm also thankful to Mr. Johnson and rest of the speakers that they put in place this workshop. And I believe that as a safety professional, we are almost dealing with working at height issues on daily basis. And it is important to discuss that what type of issues we may encounter on daily basis and how we can help our community to prevent from falling at height or whatever issues related to working at height. Let me share my screen. Okay. Just let me know once you can see my screen, please.
Yes, we can see your screen.
Okay, that's good. Working at height and fall protection are two interconnected, and hazards associated with both of them are similar. Once we are talking about working at height, we encounter mainly two issues. One is fall of the person, and the second is falling object. Both of them are killer, and both of them are serious. In my today's presentation, I will more focus on fall of person, but in my last slide, I will also slightly touch the falling object. If we go around the working at height injury statistics, like in OSHA, fall from height is one of the major, or I should say number one OSHA citations since last 5 years. OSHA is record keeping all the citations that they are issuing on daily basis, and fall protection is remaining number one citation for last 5 years. So we can imagine that how serious it is. And then if we talk about the UK 2022 statistics, 29 workers killed due to fall every day. No, in whole year, 29 workers killed due to fall, and that's over 2 per month. And this is one of the biggest cause of workplace death. And like Mr. Johnson said, that 80%, 2/3 of all major working at height injuries are caused by low fall, less than 2 meters. Whenever we are planning or whenever we are talking about working at height, we mostly focus on like 10 meter, 20 meter, or more than that. We neglect the smaller height, which is one of the mistakes that we usually do. We should not neglect the less height. Even 2 meters or less than that, there is a great potential that it can cause serious injury. I'll tell you a real incident that happened back in 2010 when I was working in Qatar. One of our construction lead man was standing on edge of excavation. The depth of excavation was just like 0.8 meter. He was standing on the edge, he slipped, he fell on the excavation and hit his elbow, broken elbow. So you can imagine that how bigger was the height. It was just 0.8 meter. So this kind of height can also give a serious type of injury. It has potential for serious type of injuries. And estimated non-fatal injuries in UK are over 441,000, which out of them 35,280 are known to approximately 97 every day. So these are quite high numbers with related to working at height. 3.9 million working days lost due to non-fatal workplace injuries, and most of them from fall from height. And the consequences of the injuries from falling from height are broken bones and week off from the work, but may have other life-changing implications. It's not just a single day pain. It's not just like one-time pain. It may 360 turn the life of a person who fell from the height. So this is something serious that as a safety professional, we need to think on that, and we need to bring some solutions in order to make our community is safe from while they are working at height. Question that why fall protection is important. This is just a rough estimation of how much time you will take to fall from a certain height. If, for example, somebody is working at 16 feet, it will take just 1 second to be on the ground from that particular platform where he's working. If it is 36 feet, like 11 meters, it will take 1.5 seconds. And like 144 feet, 44 meters, it will take 3 seconds. Do we think that in those 3 seconds, somebody can do something to prevent somebody falling from height? I believe not, right? Even the person who is falling from height, that cannot think that he is falling from height. So whatever we have to do it before start working at height. So don't let that be the last 3 seconds of your life. So this is how important it is to plan the working at height and to take all the corrective measures before we start working at height. Moving onward, when we talk about systematic approaches in protecting workers from fall, there are 3 basic approaches. And obviously, number 1 is the fall elimination. Fall elimination may not be always possible, but we have to consider the design stage and some of the engineering stages that we can eliminate the maximum fall. Second approach that we may take is fall prevention, which is in sense of providing guardrails, barriers, travel restrictions, and some of the administrative controls like trainings, discipline. The third one, which is fall arrest, use of full body harness and fall arrest in rescue. That is according to the Eric PD hierarchy of control. Okay, this is something normally people are confused on this calculating the fall clearances. Okay. I just thought out something to try to explain the attendees that how does it works. This is 6-foot lanyard versus SRL. SRL is self-retracting lifeline. You can see something, we call it yo-yo. Some other companies may name it something else, but this is self-retracting lifeline. So if you are using a full body harness, you have
full arrestor.
Yeah, fall arrestor. We may call it fall arrestor. Okay. So once we are working at a height using the full body harness, we need 17.5 feet fall clearance from the connection point. Okay. How is that? 6 feet is the length of lanyard, and then 4 feet is the elongation. Once somebody will fall and his full body harness shock observer will open, and then 1 feet is the harness stretch and D-ring is adjustment. Okay. Obviously, once full body harness will open, shock observer will open, this D-ring will take some adjustment. So considering 1 feet, and 5 feet is the height from for the person, and then 1.5 feet is the safety factor. So if we calculate this is like 17.5 feet from the connection point. It should be the maximum clearance point from the connection point. Versus if we use the SRL, then it is only just 5 feet. How? Because this SRL, this has to open within the range of 2 feet. The purpose of SRL to provide protection in case of fall, it will open up within the 2 feet of falling height. So it will not take like full body lanyard length, elongation, and rest of the distance. So it is recommended always that once working at low height, like 2 meter height or 2.5 meter height, use SRL in order to prevent worker falling from height and hitting direct on the ground. Now, once using SRL, we need to be careful because once worker are using SRL, they might go away from the working radius. And if you see the notes here, working radius of SRL should be no greater than 30 degrees. 30 degree is described in this green zone. If you go out of this 30 degree, then in case of fall, this SRL will affect like a pendulum, and worker may hit another obstruction or another structure here. So while using SRL, make sure that workers are within this 30 degree from the working radius. The further you swing, the greater force will be if you strike an object. The more further you go, the more pendulum effect, and more pendulum effect, the more striking force will come. Now, there is an update on ANSI fall protection. On June 17, 2021, ANSI approved new 2021 revision of Z359.14 safety requirement for self-retracting devices for fall protection, arrest, and rescue system. This revision supersedes the 2014 version and goes into effect on August 1, 2023, which is almost a month away, which is an important date for ANSI compliance while using self-retracting devices. So there are two type of classes of these devices and three different type of devices. Okay. These two devices we can tie off with the full body harness directly, and this type of device is used for the rescue purpose. If you see the name SRL, self-retracting lifeline, P for personal, and self-retracting lifeline R for rescue. So this is particularly the difference between three different type of lifelines. Class 1 is anchor at or above the D ring, and class 2, which is these two, anchor above or below the D ring, which is normally for the leading edge. If we have leading edge, then we can tie it below the D ring and at the foot level as well. Now, in my last slide, I will just talk about the second issue that we normally encountering while we are working at height is falling object. Falling object itself a big issue and has contributed a lot of injuries and death as well. So this is simple, a calculator that I can share later through email. If you see a particular height and whatever object is falling from height, let's say it 25-meter height, and an object of like 4 kg falls from the height. So see, it is already in days away from work case. So it is a kind of like LTI. It will fall into LTI. So this calculator gives us easy understanding that at what particular height, if something falls, how much damage it would cause us. If I change the height here like 40 meter, and I change the mass of a certain, like, let's say 3 kg, so see what it becomes. It is already in DWF system. Okay. So this is just a calculator that I wanted to share with you. And I think this presentation has added some value in our today's workshop. And if there is any question or anything additional, no problem. We can ask the question at end of the presentation. Having said that, over to you, Mr. Johnson.
Thank you. Thank you very much. I really appreciate your slide, Mr. Jamil, was very educative. You touched a lot of angles with just 15 minutes. So thank you very much for that wonderful presentation. We appreciate. Sure. We are going to give a room for Mr. Olufemi to contribute. Mr. Femi, are you there?
Yes, I'm here.
All right.
Good evening, everybody. I'm Olufemi by name, and it's a pleasure to be here again, once again. And to our regular joiners, I am sorry for not being available here last week. It was due to some things. I let Mr. Johnson be aware of that. So I will just start with this, that majority of the accidents, injuries, even death that occurs on site, it's mainly comes from working at height, fall objects, fall of people from height, and other incidents like that. So this particular topic that is being chosen today, it's a very good one. And the previous two speakers, in the person of Mr. Johnson and Mr. Jamil, they have dealt with it extensively. So I will just chip in the little I know as well. So because we keep learning every day, yeah. So working at height, I would say is just I feel say an activity we have potential that has a potential of falls. Maybe it might be people, it might be equipment, name it. And it can occur from anywhere, even on ground, like normal ground, you can fall. So that means well, falls from as in a work at height, which can lead to fall from as well. So working at height, there are activities that include the wearing of a body harness. We can use a MEWP as well. We can use a ladder. We can use a scaffold also. So either of these means we are used to work or to carry out our activities on site. So these are the means in which work from height it's occurring. Then what are the risks? I will just briefly talk about the risk that is as I align with it, which is maybe we set our scaffold on an even ground. If the tool, maybe the triggers is not being firmly tightened, maybe it's not loose, it's losing. So that's some of the risk. Equipment they're using to work on it. Then unauthorized asset as well. Then maybe we are working near overhead live equipment, or it's very close to the road also. So those are some of the risks that are attached to working at height. So I will say also want to talk about the best practices that is being required of us or the person or personnel that is going to be working at height. So the person one must be well trained, preferably third-party training, back up with regular internal training, maybe 2 weeks, once a month, depends on the company policy. Then after the person must be trained. It must be wearing his body harness. And I think maybe that will be in another topic, maybe when Mr. Johnson, body harness is on its own because it has varieties, how we stuff like that. So no, I will not be going into details in that. So the best way to use the best practices use your equipment. You want first of all you ensure that you ensure the working condition is in a good order. The distances to be negotiated for access and egress for your work to be carried out. Duration and how frequent you are going to be working in that area. Maybe it's daily work, the kind of scaffold you are going to need. If it's just maybe 10, 30 minutes or so, that one is going to be included also to enable us to know how we are going to the best loading platform or the best equipment to use. Maybe it's going to be a ladder or a MWP or a scaffold. And we have a different type of scaffold as well. So depending on that, so that's where we'll be able to know what is required. I mentioned briefly about that time, the last time, about the training here, because I want to talk about competencies of the people that will be working, carry out this activity. They all must have this competency training. That is very important. And the people that will be erecting this scaffold also, they must be third-party certified and back up with regular trainings, internal training with the company. So this will enable them to improve, because at times, I'm a professional, I know how to do this, I've been doing it for 5, 10, 15, 20 years. At times, we might maybe omit some things. So that's why regular training comes in. So whenever we are carrying out activities in such area, what we have to do is ensure the area is well barricaded. If duration, like I said at the other time, is important as well. If it's going to be a continuous one, that means maybe a fixed barrier should be around the area. If you just wait before a free period of time, you can use a warning tape depending on what you are using. Maybe soft barrier as well. So it depends also. Getting equipment to work at height. So there are many means or ways where we can get our equipment we want to use to work at height. So we will ensure that the lifting what are going to be used to carry out the load here, depending on the load we want to erect. So we are going to ensure that that all the safety procedures is being put in place. We ensure we do not omit anything, because that is very important. Then ensure that our outreaching is not is being avoided at overload. Then all other safety precautions that requires to lifting must be put in place. I will not go deep in that also. So mainly the 4-hour rescue plan should be considered for emergency situation. Maybe they're going to provide a mesh around the area. A lot of precautionary measures might be put in place prior to the task, during the task, what should be done, and after the task also. So I will just conclude by saying I believe we every day we learn every day. So it's not that we should just create a time, even if we are not going to be participating fully. Please, maybe talking or contributing. Please let's just be ensured that we listen, even if we just put a earpiece, and put our phone somewhere. Because by listening, you might pick one or two things. Our previous, maybe like 3 topics we discussed last time, I picked something. Never in my life not necessarily never in my life. In my time of having studying safety or practicing safety, I've never heard of that thing. I think I discussed with Mr. Johnson the other time. If they mention it, if they ask me in an interview, I will not know it. But where we are brainstorming, asking questions, I was able to get it. So please let's endeavor to listen and participate. Encourage more people to please join so we can learn and keep on learning and keep on learning. Thanks for having me, and I will give back to Mr. Johnson for other people to contribute their quota. Thank you very much.
Thank you, Mr. Femi. We appreciate your contribution. The topic work at height is actually a very vast one. So this opportunity is just for us to refresh what we already know, and in the process, learn one or two things that we are not so used to. Okay, so I'm learning also, and I'm sure that we are learning. So I will give the opportunity to Mr. Stephen to contribute his own part.
Okay, good evening, everyone. Like Mr. Johnson have rightly said, Mr. Stephen Francis by name. Just like the speakers have said so far and what they've been able to project on the screen, as a professional, except for those who are new on this workshop, we know these things are not 80 to 90% of what we are talking about. Some of us are projected are not new to us. Okay, and why this workshop is good for us as a professional is just like when you get a training, sometimes based on your specific role in your organization, you end up you discover that you focus on certain areas while some areas are not really be put in use because of the nature of where you find yourself in organization. So sometimes it is good like this for us to have a refresher. You know, when you say a refresher training, I would just say this is a refresher workshop for us as a professional. You know, I've been able to refresh with one or two information, but basically I would just want to streamline my discussion specifically on the procedure as I will put it. We all know the hazard associated with work at height. We all know I've happened to find have a person who I know personally who happens to fall even at ground level. You know, when the person was taking his bath, trying to come out of the bathroom, he just fell at the ground level and hit his head on the thighs and he died instantly. So now imagine somebody who is walking at some certain level of height, what could happen? You know, so, but basically as a professional, what I would like us to take home, you know, to refresh ourselves is at a company level, or maybe at a planning stage, you know, we might find ourselves in an organization whereby we get involved at the planning stage of a project, or maybe when we come in between the project and we check out those things that are available. And if we find out that some of those things are not well in place, we can just chip in certain things. Where I will go by listing out some procedures which we must take one after the other. As a professional, if the work we are doing involves work at height, first of all, we need to carry out a robust risk assessment. Really, risk assessment specifically on work at height, because this thorough risk assessment will be able to identify the potential hazard. You know, we have this general risk assessment we have and all that, but we should be able to have, because when you are carrying out the construction work, for example, and you are working on high-rise building, I think it is expected that we have a risk assessment specifically for work at height, because there we'll be able to go into the in-depth to be able to identify the potential hazard, you know, because the issue of fall might not come from the person or the worker working at height without using harness. The problem might come as a result of even the platform, even the equipment that they are using to work at that level. Okay, so proper risk assessment is very, very important. We're all professionals, we know we will not start going into depth of the risk assessment. But in this risk assessment, we're going to look at how so many factors can affect people who are working at height, how they can find themselves down, and how the objects or tools which they are using can also fall and affect people. So a robust risk assessment is very, very important. Then secondly, we look at planning and organizing the work activity. Because having carried out a robust risk assessment, this will now bring us into the planning. Because it is from the risk assessment you are able to know these are the danger, these are the hazard or risks associated. Then in the planning stage, we are going to look at, okay, what are we going to do that we reduce all the effect of this hazard and risk associated? Because in this planning stage, we are going to come up with different strategies. It is in this planning and organizing stage that we will be looking about the competency. We will be looking at equipment maintenance. We'll be looking at provision of other resources, training, and PPE and thereabout. Those things will come in. Then the third point I also have is the competency and training. It is very, very important. You know, it does not only rely on the workers, it also relies on other people. For example, if they are going to be working on the scaffold, there are people that is going to erect the scaffold. Like in Qatar now, we have a lot of local regulations that give standard to certain, like the QCS. They are going to have a scaffold inspector, right? The person who is going to erect the scaffold must be competent to do the job. Who is going to work at height must be competent to work at height. Somebody who is going to supervise the job should have that competency, you know, in supervising. Okay, so all these things will come into competency and training. Okay, so like I've said, it's not just only for the workers alone, but for everybody who are going to be involved in the process. Here they'll be making use of safety harness. Are we not going to inspect the harness? We are going to do that. So a lot of things require competency and training for us to be able to achieve a successful project without lost time injury. And you know, in going further, I will bring in the fourth one, which is equipment inspection and maintenance, just like I've said, regarding the scaffold itself, the safety harness. In some places, you'll be using an hoist system. You know, when you're working on high-rise, you discover that some certain level of work will not require a scaffold anymore. Like in the organization I worked, the company and my previous company was a service industry. So there are some level we use a scaffold because we have to go to maybe the rooftop of a building because we are working on maintenance of building maintenance system, this BMU. So sometimes these people, these workers, they need to test this equipment from the rooftop down to the ground level. So all those things, what we were doing there were like a preventive maintenance of this equipment. Even for the fact that my workers were doing this work, or my company, these workers, they are also at risk because it's work at height and all that. You know, so those are the things we need to look at, okay? The equipment inspection and maintenance. And also we have to really consider the fall prevention and protection. That is where all this equipment comes in, right? Somebody working at height, you need an harness, you need a scaffold, you need all those things that need to be done. You need a safety net and all those things to prevent some tools from falling. We need edge protection. You know, all this. I don't want to go into it because, like we've said, work at height is a very complex topic, you know, because when you talk of scaffold alone, it's wide on its own. Okay, so when you talk of fall protection and prevention, is even a topic on its own. You know, but I just try to bring out this procedure, like I've said, from the risk assessment, planning, organizing, competency, equipment inspection and maintenance. We need to look at fall protection and prevention. And the sixth one, we need to also focus on the access, because most of the fall also happen when we don't have good access and egress, you know, to this maybe working platform, or let me just say the working platform. Imagine that you erect a scaffold without a good access. Then they begin to climb like a monkey. Definitely they will just, the workers might just fall. So when you erect a scaffold or you're creating a platform, a working platform, there should be good access and egress of this working platform. And also very, very important, supervision and communication is very, very important. We need to communicate properly to these workers. We need to supervise the activity they are doing. This communication needs to be clear to them so that they understand what to do, when it comes to the activity. Then lastly, what I want to point out is that there must be a procedure for emergency in case an emergency happens, because I've seen a scenario whereby people, they are working at height and they're using safety harness and all that, even with the fall arrestor and all that. What if eventually the person drops? Does it mean you just leave the person suspended like that? When you leave the person for more than 5 minutes, with all the blood vessels that connect blood to the system, the person can die. If he's suspended for up to 5 minutes, he will die. So what are the arrangements? So an emergency arrangements need to be put in place so that even when it happens and we have all those things in place, how do we rescue such a person? I think with this, I would just like to end at this point. With this, my discussion. If we have any other person to add one or two things, I think proceed. Thank you very much.
All right, thank you very much, Mr. Stephen. We appreciate your contribution to this topic. Please, if anyone wants to contribute, just raise your hand, then I will call you and you will unmute and contribute. Okay. Now, this topic, work at height. Whenever work at height comes to play, it takes my mind to telecommunication industry when I worked for a telecommunication firm. And there is a rule that says freehand climbing is not allowed. And do you know that even though that is the most risky form of climbing a tower, workers decide to use freehand climbing instead of following the real procedure, which will allow you to gradually put your harness, anchor your harness, and move it at each step. As you are going up, you are moving your harness at each step. But just 1 second or 2 seconds of moving this harness gradually, they prefer to just fold the harness on their body and climb freehandly. So that is where the supervision comes in. If there is adequate supervision, then the procedure you already have in place will be followed. You have done your training, you have provided the equipment, you have done your inspections, and all the equipment are all okay to use. You have even done refresher training. You did 2 bus stock before the activity started. But human error and human factors are always there. So supervision should not be overemphasized. For each work activity, there should be a dedicated supervisor, not someone that goes and comes, or someone that goes and comes. Because just 1 second, just like Mr. Jamil shared, that falling from a height of almost 144 feet just requires just 3 seconds for you to hit the ground. So the reaction time is not guaranteed. You cannot react to anything in fall from height. So supervision is very, very important. If possible, dedicate a safety personnel. If that work at height is very critical, dedicate a safety personnel, if not just a supervisor, because some supervisors, sometimes they collude with their teammates to do unsafe acts. So if health and safety personnel is available, there is possibility of them following the procedure. So we should consider adequate supervision to ensure that people follow the procedure while working at height and prevent any possible incident from work at height. Okay, Mr. David, you raised your hand. It's time for you to contribute.
All right, thank you very much. Everyone that has spoken has been amazing. And of course, if we keep on discussing and talking about this topic, I mean, 24 hours wouldn't be enough to really touch on everything that has to do with working at height. It's really an interesting and sensitive, wide topic. However, I would want to chip in one or two things to the presentation made by Mr. Femi, because he actually focused on the controls of working at height. And I think the other speaker that have left also focus on personnel falling from height and not objects falling from height. Just the 2 points I wanted to add to what Mr. Femi, all the controls he has already mentioned to mitigate a fall from height. Two things. I think when lifting materials to height, you know, if the materials are heavy materials, you want to install a gin wheel or a pulley to lift heavy load. Then why for the smaller loads, all materials that are very light, maybe less than 5 kg, you may want to use a tools bag, you know, to put this material on your tools bag as a worker, and also maybe a push bag to send those materials to height. Then secondly, like Mr. Francis, Mr. Steven, like he said, focusing on materials, equipment that could create the potentials, you know, for materials, tools, or things falling from height. So for workers who basically work at height, they need to secure their tools with the hand tools lanyard or Tara. So that will help to prevent the tool from just dropping to the floor, to the ground level at the same time. At least it will suspend the tools will dangle, will swing, then you can, again, the worker can retrieve that tools. Now, coming over to the first presentation that was made by Safeoclock, you know, he gave us some statistics and all of that. Yes, that was quite good. I think the work at height regulation, as at 2005, there was an amendment that was made as per the Health and Safety Act in UK. So the Work at Height Regulation Act for UK was amended in 2005, and that was where that definition of fall from the same level, you know, falling into a hole, was really enacted or developed. So I would also want to share, just I think this week we recorded 2 fall from height cases. You know, there was this QC guy who was actually going for an inspection. So, but he decided to take a shortcut. He saw where they stored they kept the steel Chinel structural materials, and there was a lot of white space he could have, you know, routes he could have taken, which was very safe and clear. But the guy decided to step on the Chinel beams, and in the process of doing that, you know, he slipped and fell off to the ground. His head landed on the steel structure on the floor, so he sustained some minor injuries. And in the process of falling, he was trying to, you know, guard his face by putting his hands in front of his face, and of course, he sustained a scratch on his hand as well. And that made us to record a first aid case, you know, this week. I think there were about 2 cases like that has to do with fall from height. These 2 just happened same week, this week, from Monday to now. So that goes to tell us, like the statistics that I've shared, the trend where it is said that, you know, working at height is one of the major and leading causes of, you know, injury or incidents in the construction site, and also for even less KPIs, like for example, LTI and you know, first aid cases, medical treatment cases. So work at height is something that should be given thorough attention in any workplace. And lastly, and as usual, I'm the one that always, you know, asks the question. I want to pop up a question, you know, let's crack our brain around it. In my current place of work, I actually did develop a robust system on working at height, just to roll out a campaign on work at height. Because when we're starting, like Mr. Steven said, one thing I basically do anywhere I go, I do a gap analysis, So, and I call it a daily management system. So I go to the site, look at the things, the area, the aspect, the system where they are actually doing good. Then I also look at the areas where they are having gaps. So I identify both. Now in the safety meeting, I begin constructively with the areas they are actually performing, doing great. I can share with them and tell them, oh, you guys amazingly, in fact, I saw this, I saw that, this is good, that is good. Then gradually I will chip in. However, I think maybe we could do this, just like a subjective observation. Maybe we could do this, we could do that, just to improve the system. And while I was doing so, that was when I discovered that, oh, they have not really paid any attention to work at height. So I had to go back. When I shared with them, I discovered that a lot of persons were confused. They don't know what to do, to be able to, they don't know how to go about the program to be able to do that. So my superior and my boss, my manager, just challenged me and said, okay, David, you were the person that spotted this problem. You are the person that have mentioned it to us. So you should handle it. Do whatever it is you want to do to make sure that we are able to control this risk. So, and that led me with, I just smiled over it, and I had to go back to develop a robust drop object campaign. It was really a deep one. And in the process of doing that, there was something that I tried to, even to today, there are a lot of controversies, confusion, because some persons did challenge what I offer, what I brought to the table. There was a project I work in Shell, and in that project, Shell, as per their calculation, when it comes to drop zone, they tell you that for every 3 meters height, vertical height, okay, you should give 1 meter horizontal distance at. So if we are having a height of 9 meters, then it should be 3 meters. So that was the system I was using in Shell. But however, when I was developing the system and I rolled it out, I was campaigning and I launched it. Now, someone challenged me in the process of my presentation, and they tend to refuse that, no, they don't accept, what I've said, that the calculation I've given, or what I've said that for the drop zone should be like this. For every 3 meter height should be 1 meter. So yeah, I want to pop up the question by asking, how do you determine the drop zone, for working at height, and which standard supports whatever answer you will share? Because I actually did a research on that, and I couldn't place my hand on any standard that really supports, the drop zone, apart from the drop object.org, because that was the site I actually got a lot of information and materials I work with then. So apart from them, they just gave some calculators that you can use, to make the calculation, but it wasn't really clear, like in the aspect of, using human, for their analysis, and using tools for their analysis. So I don't know if anyone in this platform have any idea as regards to how to determine, to calculate the drop object zone, and what standard supports that, what formula supports it. Thank you.
All right, thank you, Mr. David, for your contribution. Second, for the challenge question as usual. Okay, I'll just speak for a few minutes, and I will allow someone else who has an idea to contribute also. So from what I know, I cannot lay hands on the regulation to back it up now, but I know I've read from somewhere that we should consider 1/3 of this of the height for each vertical height then 1/3, just like 1:3 ratio. Okay, just like in the case of ladder. Okay, ladder you say is 1:4 ratio. Just as the distance increases, then you give one ratio distance to for the what is it called for proper alignment as the ratio. Okay, so what I read is that for each height, the drop zone should be 1:3 ratio. Okay, so that is the information I have. I cannot back it up with any regulation, but I would need to research on that later. So if someone else has more concise information on that, you can share. If there is no one with more concise information, then we'll take it as a take-home assignment. We'll go and research and find out regulations backing up a drop zone.
It is well noted, sir.
I want to ask Mr. David one other question. Though he asked the question, but I'll throw a question to him also. So,
All right, go ahead. Go ahead.
I don't know. Based on this drop zone, does the meter, in terms of does the vertical, the horizontal, vertical horizontal, does the horizontal distance determines does the weight of this object determine the distance as well? Because I'm just trying to read, because I'm just trying to look at this whole scenario. If an object, which is like, maybe for example, maybe an object that is 1 kg, you know, for example, I'm just trying to visualize an object that is like, maybe let me just say 5 kg is dropping at 3 meters or thereabout. And based on this shell standard you gave, now, if, for example, this object is like 100 kg, for example, you know, will you still have the same horizontal distance? Because I'm just trying to picture out the whole thing. If object at different kg will have to fall, and maybe because of the impact it will have on human, that is why we are giving that distance. So I'm also trying to relate it with the weight, the general weight of this particular object. If you have experience from shell, which you have worked from.
All right. Thank you for that interesting question, I would say. Firstly, there are 2 ways to this question. There are 2 ways to tackle this question you've asked, and that's why we have the drop object calculator, like the speaker, you know, presented in the last page of his slide. Now, that drop calculator helps you to determine the consequences of an object, okay? The consequences of an object. So we have the height, which gives us, measure the meter, and of course, the mass which is the load. It could be the mass of, it could be human, it could be materials, it could be tools. Now, based on that calculator we have, is the calculator has been calibrated, you know. They've done a lot of research. They've made all these analysis, all this calculation. And so what the calculator does is that when they get the load, the weight of the load, and also the height, automatically it will be classified to the various category we have. We have the fatality. Then next to the fatality, as per the pyramid, right? So first we have fatality. Then next to fatality is LTI and day away from work. After LTI and day away from work, we have the medical treatment case. Then below, which is minor, is first aid case. Now on the chart, the drop zone chart, you will see it there. So depending on the mass, which is the load, and the height, so that gives you the consequences, telling you that if so objects with so weight, you know, fall from this height to the ground, and touches someone, this will be the consequence. It could lead to either fatality, it could lead to a medical treatment case or a first aid case. And secondly, coming to the drop zone, like we have said, the 1/3, okay? So in case of the 1/3, the weight does not really play here. It does not have any impact or effect. So it doesn't matter the weight of the load, or it doesn't matter the weight of the load, okay, and the height. As it is calculated and designed as per shell, is that whether it's 100 kg, whether it's 50 kg, if you are walking 3-meter height, if it falls, it's not going to exceed 1 meter on the ground. If it falls from that 3-meter height, it's not going to exceed 3 meters on the ground. And there was still another formula. That's why I say it's really complex. That one is called the cone drop object. So they still want you to consider if an object falls from a 6-meter height, and maybe there is an obstacle on the way, and it hits on another object or platform, it could deflect. You understand? It could deflect to another direction, you know, thereby exceeding the calculated safe distance. So, however, I've been applying that 1/3, and it has been working for me. You know, it has been effective. So, but just in my current place, someone asked that question, and that's why I've also done my research, but couldn't place my hand on any standard supporting the 1/3. It was really difficult. The only thing you can find is a procedure, maybe one company's procedure, and it's stating the obvious, stating the same thing, 1/3. That's what I've seen, but I think maybe it could be out there. So that's why I've shared to see if anyone could lay his hands on it.
Yes, well, let me just say something. Just like you said, we'll try on our own to go and find out if there's any regulation on that. Because I'm trying to check something on the internet now, but I'm discovering that there's an information being supplied by the electricity supply industry regarding drop zone management. I believe this question is a very wonderful one. And by the time we will make our personal research, I believe we should also come up with a presentation that has to do with a drop zone management precisely, because I believe it's going to be a good and robust interactive, because I've not really seen people discussing much on this aspect. So I think it will give us an opportunity to go in and get more information. And these are the things we are talking about. These are really what we are talking about from the beginning. So
can we make it next week topic? So it will be challenging for us to just use this 1 week and gather enough information so that we will be able to discuss it robustly. So I think it's a very interesting one, and it's going to be very informative, because you know, we just in most cases we just barricade anywhere we feel like.
Of course.
We just barricade under the load and just under the working environment, and we don't consider the distance where the material could drop.
Objects, yeah.
So if we are able to come up with concrete information that that is tangible enough to pass to others, I think it will be very nice. So instead of prolonging it, let's challenge ourselves within 1 week. From now till next Thursday, we'll be able to come up with a robust presentation to back ourselves up and learn more.
Okay. Thank you very much. I think in this case, I would also want to add another question. So maybe we could also consider that while we go back and see what we can come up with. So let me put the scenario this way. Maybe group of scaffolding guys working at a height of about let's say 6 meters height, okay? And one of the scaffolders happened to fall. It was a free fall. He's putting on his fall arrest system, full body harness, and it's tied up 100%, but he suddenly just, he loses his balance and suddenly fell over, and he's been suspended by his the lanyard, okay, of his full body harness. So that puts him in a suspension trauma, right? He's at a suspension trauma. So how long will it take for him to maintain his breath before it's being rescued from height? Because around this type of scenario, there've been so many controversy. Some company will tell you 4 minutes, okay? 4 minutes, that person, the IP must have been rescued from that position. Otherwise, it might, the flow of blood, might stop and he might lose his life. Some other company will tell you 6 minutes. Some will put in their procedure 10 minutes. So I don't know if we can be able to get a concrete, because that's the golden minutes. It's called golden minutes, to rescue the IP, the victim, from that suspension trauma. So how much minutes is allotted, is allocated to rescue a victim who is at the suspension trauma position at height? So maybe we can also do a check on that as well.
Yeah, I know 10 minutes is out of it.
Yes, so completely out of it.
If I could remember, maybe between 3 to 5.
Shell is still 4. Shell is 4 minutes. But I still had people who challenged it and said, no, it's 6 minutes.
We'll check it out to see any regulation, any regulatory standards.
In most cases, some of these are considered in best practice opinion. So even though that there might not be a regulation backing it up, then industries come up with their best practice. Yeah, different industries comes up with a best practice, and if you are in those industries and you decide to abide by them, then it becomes a best practice for you. So, but we are going to add it up. Then if we're able to get different information from different industries, so that we can even say in social industry, this is the recommended best practice minutes, and in social industry, construction, oil and gas, telecommunication, electricity. So if we're able to get best recommended time for different industries, so that we'll be able to have a vast conclusion, you understand? So that we will not be so restricted to a particular information, whereas in a different industry, something else applies.
Yeah, that's a good one.
Likewise.
Okay, we have done even beyond our time today. I'm so glad that we chose this topic today and we've done justice to it.
That's the effect of Mr. David. He's always dropping something to take us home so we can.
Yeah.
I'm loving it by the day.
Yeah, thank you guys. So next week we're talking about drop zone management. So we have something to work on before Thursday. All right, guys, have a nice day.
And you too. Thank you guys for attending.
Okay. Happy Eid. Happy Eid. Yeah, happy Eid. Eid Mubarak.
Eid Mubarak.
Eid Mubarak.
All right now.
All right, guys. See you.
All right, bro. Yeah. Yes. Have a nice weekend.
Yeah. Thank you.
I'm still online. Mr. Femi,
yes.
During the time you were speaking, you made